9.2 verifying trig equations. So this is going to go very well with 9.1. It's going to look a lot like what we did in 9.1, but I'm going to go through this kind of quickly. So if there's anything that you're kind of lost on or not sure where an identity come from, make sure you stop your teacher and ask them where it came from, because like I said, I'm going to go through this pretty quickly. So some guidelines for verifying trig identities. You're going to work with one side of the equation at a time. It's often better to work with more complicated side, because it's easier to take something that's complicated and simplify it than it is to take something that's super small and try to make it bigger. Look for opportunities to do algebra, such as factoring, adding fractions, multiplying your conjugates, things like that. Look for opportunities to use your fundamental identities. So those are your ratio or reciprocal identities, your quotient identities, and your Pythagorean identities. If the preceding guidelines don't help, try converting everything to sines and cosines. Always try something. Even if you get to a dead end, it might provide insight. And then keep in mind there may be more than one way to do this. So just because you do it one way and the person next to you does it another way doesn't mean you guys are wrong just because you did it different ways. Alright, so we're using the same identities from 9.1, so I'm not going to go through these again. I am going to reference them throughout these notes, but I'm not going to keep scrolling back and forth. So if you need to, during this video, pause and look for the identities, and then we'll take it from there. Alright, so this says verify whether the following is true or false by simplifying one side of the equation and determining if the left side is equivalent to the right side. So what we're going to kind of think of doing is this equal sign is kind of going to be your median. So we cannot cross that, meaning we can't move this cosecant squared x on the right over to the left side, and we can't move anything that's on the left side over to the right side. We can work on both sides separately, but we just cannot cross over that line. Alright, so I'm going to work with the left side because the left side is more complicated. It says sine squared over cosine squared plus sine x cosecant x equals cosecant squared x. So the first thing I'm going to do is I'm going to work with this cosecant x. So I'm going to rewrite this. I have sine squared x over cosine squared x plus sine x. And I'm going to change cosecant x using our reciprocal identities at the top to 1 over sine x. Now that I have multiplication on the right side of this plus sign, I can cancel the sine x's out. So I'm left with sine squared x over cosine squared x plus 1. Alright, the next thing I could do is I could look at my quotient identities, and my quotient identities say that tangent equals sine over cosine. Well, I have sine squared over cosine squared, so I'm going to change this to tangent squared x plus 1. And then I can look at my Pythagorean identities, and I can see that tangent squared plus 1 equals secant squared x. So it's in the middle. So we have secant squared x. Well, if we look at the right side of this equation, we wanted it to equal cosecant squared x, which is not what we got. So these are not true statements. This is not equal, so this is a false statement. These do not equal each other. On the next one, number 2, we have secant x times sine x plus cosine x equals 1 plus tangent x. So again, we're going to work with a more complicated side, which would be the left side. So we can go about this two ways. We could change secant and get everything into sines and cosines. That's one way to do it. Or another way, we could start with our algebra and distribute the secant x into our parentheses and then change everything to sines and cosines. So you kind of make the decision of what you want to do. I'm going to change everything to sines and cosines first. So I'm going to change my secant x to one of my reciprocal identities at the top, and I'm going to change secant to 1 over cosine x. And then I'm just going to have it multiplied by sine x plus cosine x. Alright, so when we're multiplying this and we're distributing this in, what you kind of have to think about is I'm going to multiply the numerators together. So think of this sine x and this cosine x over 1. So I'm going to do 1 times sine x, and I get sine x, so that's multiplying the numerators, and then I'm going to multiply the denominators. So now I'm going to do cosine x times 1, so I'd get cosine, or sine x over cosine x. Now I'm going to distribute this cosine, 1 over cosine to cosine x. So 1 times cosine x would be positive cosine x, and then distribute the denominator, cosine x times 1 would be cosine x. And again, if you need to draw that line of what we can't cross, you can. Alright, when I look at this, if I look to the right side of this plus sign, I have cosine divided by cosine. Well, anything divided by itself is 1. So I know this is going to change to 1. I can also look under my quotient identities and see that sine x over cosine x changes to tangent x. So I get tangent x plus 1. Well, look at what we wanted it to equal. We wanted 1 plus tangent x. So these are the same statement. So this is a true statement. These, both sides of this equation match each other. Let's go to the back. Number 3 says cotangent x times sine x times secant x equals 1. So since it's multiplication, what I'm first going to try to do is I'm going to change everything to sines and cosines and see if anything cancels. So if you look under your quotient identity, you can flip your paper over, you will see that cotangent x equals cosine x over sine x. The middle term is already a sine x, so I'm going to leave it alone. I'm going to leave it sine x. And then secant x, under our reciprocal identities on the other side, you can see that secant x equals 1 over cosine x. So I'm going to change this to 1 over cosine x. And we're going to try to make all this equal 1. So if it helps you, you can put that sine x in the middle over 1 so that you can remember it's in the numerator of the fraction. So now that it's multiplication, I can go through and cancel everything. So we got sines can cancel, we have cosines can cancel, and even our 1's cancel. So if everything in your equation cancels, that's like everything is being divided by itself. So we have 1 whenever we do that. So we have 1 equals 1. So this is also a true statement. Alright, number 4 says tangent squared x over secant squared x equals 1 minus cosine squared x. So I'm going to work with the left side. Honestly, you can work with both sides, so just to show you, I'm going to change everything to sines and cosines just so I can get started. So I have tangent squared x, so I'm going to look under my quotient identities on the other side, and I'm going to change tangent squared x to sine squared x over cosine squared x. So since our tangent was squared, we're going to square our sine and our cosine. Then under our reciprocal identities, I can see that secant squared x can change to 1 over cosine. So this is going to change to 1 over cosine squared because our secant was squared. And then on the right side, remember I cannot cross, I can't move anything from the right side to the left side or anything from the left side to the right side, but I can see that 1 minus cosine squared, if I look under my Pythagorean identities, is sine squared x. So I'm going to kind of work with this. Alright, so on the left side, I have a fraction divided by a fraction. So that means we're going to keep, change, flip whenever we do this. So what I'm going to do is I'm going to keep the top fraction. So I'm going to keep sine squared x over cosine squared x. I'm going to change it from division right here to multiplication, and I'm going to flip the bottom fraction. So it's going to become cosine squared x over 1. Now that it's multiplication, I'm going to look to cancel. So cosine squareds would cancel. So right now I have sine squared x over 1, which would just be sine squared x, equals sine squared x, which is what we wanted. So this is a true statement. Let's go to the next one. Number 5 is called a conjugate because we have tangent x plus secant x times tangent x minus secant x. So whenever you have the same exact terms in your parentheses, but the signs are different, one's positive and one negative, that's called a conjugate. Let me write this out. So a conjugate means whenever you FOIL these together, your middle terms would always cancel out. So you don't have to do a complete FOIL. You can if you want or you forget how to do this, but if you can remember it's a conjugate, all you really have to do is first times first and last times last. We don't have to do the center terms of FOIL because those would just cancel each other out. So if I do first times first, I would get tangent squared x. If I did last times last, I'd have positive secant x times negative secant x, which would be negative secant squared x. Alright, and we're trying to get this to equal 1. So if you look under your Pythagorean identities, you're going to see one that looks kind of like it. You have one on there that says secant squared x minus tangent squared x equals 1. Well, ours is backwards from that identity. So instead of it equaling positive 1, since it's backwards, it's going to equal negative 1. So we have -1 equals +1, so this is a false statement. So again, if you need me to tell you more about what that means, on your identities, under Pythagorean identities, it says secant squared x minus tangent squared x equals 1. Well, if you notice, ours says tangent squared x minus secant squared x. So if you look here, see how the secant up here is a positive value, but down here it's a negative? And then in our identity up here, the tangent's a negative, but down here it's a positive. So all the signs have flipped. So that means we have to flip the sign on the answer. So it's going to be a -1. Okay, number 6, we have sine squared x plus sine squared x times cotangent squared x equals 1. So if we notice, we have a greatest common factor here. So if we have our greatest common factor, we're going to factor out a sine squared x. So if I factor out sine squared x, we have to think about what's going to be left. So if I take sine squared x out of that piece of our equation, I wouldn't have anything left. But there has to be a placeholder there, and our placeholder is a 1. Plus, now I look to the right side of our plus sign, all of this. If I take sine squared x out of that piece, I'm just left with cotangent squared x. So now if you look under your identities, you'll see that under your Pythagorean identities, it says 1 plus cotangent squared x equals cosecant squared x. So I'm going to change what's in our parentheses to cosecant squared x. And I'm going to leave sine squared x out here. Well, what do we know about sine and cosecant? We know these are reciprocals of each other. So we can look at our reciprocal identities, and we know we can change cosecant squared x to 1 over sine squared x. Here, the sine squareds would cancel, and we get 1 equals 1. So this is a true statement. All right, number 7, same thing. I'm going to work with the left side. And again, we have a GCF. We have common factors. So we have a greatest common factor. So if I look over here, I'm going to say, what is the greatest common exponent I can take out of both of our cosines? So I'm going to take out a cosine squared because they go into both of those. So if I take out cosine squared and I take it out of this piece, I would be left with nothing. There would be nothing there, but I have to have a placeholder again. So I'm going to put it at 1 minus. If I take cosine squared out of this, I would have 2 cosines left, so I'd have cosine squared. Again, once we do that, we're going to look on our identity sheet under the Pythagorean identities, and you'll see that 1 minus cosine squared x changes to sine squared x. And then we still have times cosine squared x. All right, so look at what we're trying to get to. We're trying to get to sine squared x minus sine to the 4th x. So we've already changed half of it to sines, which is what we needed. So we got to somehow figure out how can we change cosine squared to have sines in it. So if you look under your Pythagorean identities down on the bottom left, do you see where it says that cosine squared x equals 1 minus sine squared x? That's what we're going to change cosine squared x to. So we're going to change cosine squared x to 1 minus sine squared x. And then we still have times sine squared x. And this is kind of different. It's not something that you're used to doing, but you're going to distribute that sine squared x backwards into that other identity. So when we do that, sine squared x times 1 would be sine squared x. Sine squared times negative sine squared would be negative sine to the 4th x. So that matches what we needed. So this is a true statement. All right, last one. We have tangent squared x plus 1 times cosine squared x minus 1. So both of these are Pythagorean identities, so you just have to look on your sheet and find them. So if you look, you'll see that tangent squared x plus 1 looks like the one that says 1 plus tangent squared x equals secant squared x. So we're going to change this one to secant squared x. And then we're going to change cosine squared x minus 1. It kind of looks like the one that says 1 minus cosine squared x equals sine squared x, but it's backwards. So we're going to make this negative sine squared x. I'm going to go ahead and change secant squared x to 1 over cosine squared x. That's under our reciprocal identities. And we're going to multiply it by our negative sine squared x. And if it helps you, put it over the 1. The 1's cancel, so we get negative sine squared x over cosine squared x. And if you look under your quotient identities, we get negative tangent squared x. Well, if you look at the right side, we just wanted negative tangent x. So this is a false statement because the left side was squared and the right side was not. So again, guys, sorry for the bell. If there was any part of this that you didn't understand, please make sure you stop and talk to your teacher and ask any follow-up questions. Have a good day.